Thank you. So we have one more speaker before we take a break. The next speaker is on Zoom. So we have Nikos Manousakis at the Academy of Athens. So he specializes in ancient Greek drama and computer linguistics. That's what he's done his PhD on. And he's going to be presenting a paper on applying automated authorship to Greek drama. Let me see if I can make him a poster here. Let's see if I can find him. Nikos. Oh yeah, there we go. Okay. Make photos. Okay, Nikos, if you're there, you can now share your screen.
We can't hear you.
You can hear me?
Oh, now we can.
Thank you.
Great.
Welcome.
Welcome. So if you just share your screen.
Thank you. Thank you.
Okay, we can see that. Thank you.
That's great. Hello, thank you for having me. This is a great opportunity to talk about my work and be with you all. Unfortunately, I couldn't be there, but in the last 5 years, I have applied a series of authorship attribution methods to disputed or partly disputed texts in the corpus of Greek drama. Rhesus, attributed to Euripides, Prometheus Bound, attributed to Aeschylus, the problematic ending of Aeschylus 7 against Thebes, the controversial recognition scene in Euripides Electra, and we are now working with my colleagues on Prometheus Unbound, on the fragments of Prometheus Unbound. The authorship attributions method I have applied to these texts range from visualization models to artificial intelligence algorithms. I will talk to you now mainly about work that has been already published or will be published soon. I have sent to the organizers of the conference intro and kind of summary of this talk. So for anyone who wants more details about my work and want to know about the papers and the book that I have published, you can find it there. So let's begin. Machine learning and artificial intelligence and neural networks and now language models began when Alan Turing envisaged a thinking machine, a machine that could communicate with people. And now the major milestone, if you have heard Geoffrey Hinton resigning from Google recently, you know what's going on. You can understand like the hype that's has to do with artificial intelligence. A good friend of mine who's a computer scientist says that artificial intelligence is to make the machine, to make the computer do what it does in the movies. And I believe that that's like quite accurate. And many people except me kind of believe that. You know, I think that many of you had like played on with ChatGPT. It's the latest thing, the latest trend on artificial intelligence. This language model is, I mean, very interesting thing. I don't know how many of you know that ChatGPT speaks ancient Greek, that you can like give to the Greek text to the model and ask question about the Greek text, and I inform you that it composes Greek text. What you see on the screen is what I did with, it's like a game I did. I asked ChatGPT to write a line in the style of Euripides about love. And that's what the machine answered. Of course, it's not metrical. It's not important, but it's something. And we can all understand what will happen in the future. If this is possible now, I just asked the model to write a line in the style of Euripides, and that's it. Now, more about authorship attribution in silico. Authorship attribution is a procedure that has like much, like it's very much like a detective mystery. You have a text that many people believe that is ascribed to someone. Many people believe that it was composed by someone, by an author, a very famous author, mostly. But like other people have doubts. Some of these doubts are ancient doubts. Some are modern doubts, and you have to find a way to like draw conclusions about it. Like, is it or is it not? Like until very recently, like 5 or 6 years ago, we only had connoisseurship. We only had like people knowing very well the work of an author and like drawing conclusion about some texts based on their knowledge, on their personal knowledge of an author. But today, now we have something else. Now we have machine learning, which is unsupervised and supervised. We have got algorithms that process a set of data containing all the inputs and detect structures in the data, such as groupings of data. These algorithms learn from the data that are a priori labeled, categorized, instead of processing data that are set under specific labels, specific authors. Unsupervised learning algorithms detect commonalities in the data and act on the basis of the presence or absence of such commonalities in the new and seen data they receive. They generalize their knowledge. That's the basic thing. And we have also supervised algorithms tied to the cognitive, philosophical, pedagogical, and concept of learning by example, in that there is some training of reference material, a set of examples of known metadata, authorship chronology and stuff involved in the process, though through which a model is able to reach some decision about the status of a problematic entity, a text. That is, there's a training session during which a problem is given to a learning agent, as well as the solution to the problem. I mean, we give the machine like 5 texts by Sophocles, and we tell him that these are texts by Sophocles. The agent learns, understands through the process what's the style, I'm going to talk to you about more later, of Sophocles, and then you can give it another text that's problematic and can tell you if it's by Sophocles or not. I'm sorry. Style and trace, that's the thing. What I wanted to talk to you about when I mentioned style. Style is a problematic term because it belongs like to the past. We are beyond style now. And I coined the term trace. It's the imprint an author unintentionally and unconsciously leaves in his writings. It is tied to linguistic style. However, it examines the core of written language production, boiling down to the tiniest fractions, meaningful and meaningless, combinatorial mechanics of letters, sounds in the texts, which, for practical reasons concerning the capacity of the human memory, remain outside the author's conscious control. To open a parenthesis here, this photo is artificial intelligence, is auto-generated. Photo is from the DALI program. Some of you may know it. I asked the program to generate a picture of Aeschylus and Euripides in the comedy of Aristophanes, The Frogs, and that's what I got back. I didn't give the machine the model any other information. I just asked it to give me a picture of Aeschylus and Euripides, and I mean, look at the faces, like the sneer and stuff. Okay, to go on. The trace. Trace indicators can be based on lexical distribution of words or defined sequences of words, vocabulary richness, word sentence length, grammatical, syntactic distribution of parts of speech or of syntactic structures, character distributions of character sequences. I'm going to talk to you about this more. strings of n successive letters and symbols by one, unigrams we call them, two bigrams, trigrams, fourgrams, etc., or of semantic features, distribution of synonyms, semantic dependencies, lexical and character indicators are conveniently enough for us, language independent. The machine representation of the text, I mean, what the machine gets is one of these. We have these choices for the machine representations of text, like the semantic, the lexical, and stuff. The machine has to get a representation of the text so it can process them and give some answers. Our best options right now, the best representation, the best trace indicators we have now, for the past years have been the most commonly used words, like function words, pronouns, prepositions, conjunctions, because as you all understand, this are used very frequently in text. So you can draw like more stable conclusions, more robust conclusions based on these words, contrarily to base your conclusions on content words. But now we've got character engrams. Character engrams are like very fascinating because the problem with like working on text and trying to find out like their authorship is that we have so few data. We've got like 7 plays by Sophocles. We've got more by Euripides, but okay, we also have few in comparison to how many he wrote, and we have like 6 plays by Aeschylus and 1 that is, as I am arguing, not by him. But character engrams that I will show you what they are right now are like hundreds of thousands in the text, and when you can like go through hundreds of thousands of these entities, you can have like more stable draw more stable conclusions and get answers. Character engrams are defined here as consecutive letter sounds in a piece of text between words included, but punctuation marks excluded. The text is used in the automated analysis, do not attempt to reproduce the manuscripts, but are rather based on the editorial tradition as regards spacing and stressing, which are in the main the product of an indisputable consensus. On the other hand, punctuation marks, especially the comma and Greek semicolon, and less so the question mark and full stop, are much more arbitrary. That's why we don't use them. Character engrams are neither morphemes nor words. They represent an intermediate linguistic state capturing both morphemic and lexical data, as you will see. The length of n bigrams, trigrams is based on the needs of each individual study. The relative length of words in the language studies about the length of the disputed text, and the text we have is a very important thing. And this is exhaustively tested with texts of known authorship before is applied to any controversial material. For instance, like trigrams constituting the first 2 words of line 56 in Euripides Electra. I've been working on Electra. There's a paper that will be published in classical philology very soon, so that's why I'm giving you these examples from. Perusa pigas would be fer, erro, ro. You can see the rest. Or like line 152 in Aeschylus's Hoifore is, you can see the trigrams here. We have to choose like between, we mainly use trigrams, 4 grams, sometimes 5 grams and 6 grams. The smaller the string is, the precision is better, but there are also many that you can have mistakes. So if you use unigrams, if you use bigrams, things are not like very stable. So the experiments have shown that you have to go from trigrams and up. The techniques that I have used with this text are style change analysis, principal components analysis, agglomerative hierarchical clustering, Barrow's delta, support vector machines, common engrams, and engram tracing. I wish I had the time to talk to you more about them. I mean, each one of them, but this is a graph from Prometheus Bound, and it is from, I'm sorry. Oh, sorry. This is a graph from Prometheus Bound from style change analysis method. Style change, what style change analysis does, it takes the texts, only the texts that is ambiguous, only the text that you want to know the authorship of, and starts by saying like the first 200 lines we think are from Aeschylus. Let's compare these 200 lines with the rest of the text, and then goes to the next 200 lines and the next, or 100 lines. 200 lines is just like, for instance, what we can see that way. We can see if there are like problems in the text, in the change of the style, in the change of the trace, like if there's any change of trace between the first 100 lines and the second and the third and stuff. And what we can see through that is we can understand if, for example, this was used very much on Shakespeare, if a text is co-authored, if like 2 or 3 people. And when I say co-authored, I don't only mean like that Aeschylus or Euripides co-authored a text with someone, but someone other than Aeschylus at some point in antiquity tampered the text. That's a form of co-authorship that this method checks. This is an example also from Prometheus Bound, is the unsupervised analysis. We use like the 90 most frequent words. You can see them, and it allows us to group. I told you it's an unsupervised model. It doesn't know anything. It just takes for input that these are some texts that you have to put them in space, closer to others or not. Principal component analysis is the name of the method. You can see the first graph is with the 90 most frequent words, and we use 90 here because we use the Iliad in the Odyssey too, and with less than 90 words the results were not very good due to the 2 epics. They mixed the results, but with the 90 most frequent words, as you can see the PCA, the principal components analysis, works like very good. And the second one is, second graph is about our work on Prometheus. Again, you can see that Prometheus is like far from Aeschylus, but very near to Euripides and Sophocles. And you can see that Aristophanes is on its own, but due to the tragic language, as we say, all the tragedians are on their own side. Here we used only 24 most frequent words. The next method we use support vector machines, like the most robust method, until very recently, given a set of training examples, each mark as belonging. I mean, we give the model the information about the authors when we train the model. each marked as belonging to one or the other, specifically two categories. An SVM training algorithm builds a model that assigns new example generalizes to one category or the other, a binary linear classifier. That's what we get. The first objective of the algorithm is to find a hyperplane to cut a partition of the feature space into two categories. Authors, when I say categories, I mean in an n-dimensional space, and the number of features used in the representation that has the maximum margin between the authors. That's what we want to achieve, like the maximum distance between the two authors, the data points, like the texts belonging to the authors that are a priori assigned to a certain class. N-gram tracing. That's what we recently used with Electra, talked to you about, and the final part of Aeschylus' 7 against Thebes. This method is used to calculate the percentage of all engrams occurring in a question text, character engrams, and also at least once in a candidate author's writing samples. This is done for all candidates, and the text is attributed to the author whose training sample contains the highest percentage of engrams in the question document. By extracting the complete number of engrams occurring in a suspect text, one obtains a broad and unbiased feature set. That's what we're looking for. In fact, the model measures the percentage of engram types found in the suspect document that also occur at least once in equal size. That's very important, equal sized samples in terms of the total number of features from each candidate author. Only the presence or absence of these engrams in the question document and the candidate author's samples is considered, not to their relative frequencies, to avoid the bias of relative frequencies in very short texts. To make sure the results will not depend on limited sampling, the analysis can be repeated on several different random sequences of texts, and the average cumulative percentages of engrams detected there can be calculated and plotted at regular intervals of the total features. The suspect document is then attributed to the candidate author with the highest overlap coefficient. The size of the smaller of the two sets as its normal number of features. Okay. Let's go to to see the examples that we have worked on. Rhesus. Rhesus is a text that's, there have been doubts about its authenticity since antiquity. Ancient authors are saying that like the style of this play is not like quite Euripidean. The thing is that when we examined Rhesus using various methods, and the conclusion was that it was half attributed to Euripides and half to Aeschylus. That doesn't mean that it was written by Aeschylus and Euripides together. That doesn't mean that at all. But we had to draw a conclusion about why this was happening and why robust models such as support vector machines were giving a result that was attributing like part of the text, but not like half of it to Euripides and half of it to Aeschylus, but like 100 lines to Euripides and 150 lines to Aeschylus. The result was quite mixed. Our conclusion, the conclusions we draw, based on an idea that Vaios Liapis, another scholar of Greek, has, that the play was written by an actor, is that probably if this idea of Liapis is right, someone who was an actor and had in its repertoire Aeschylus and Euripides, but not Sophocles, but because Sophocles or Aristophanes, because they appear nowhere in our results, wrote a text, wrote this play, and at some point in antiquity, it was thought to be the work of Euripides. let's go to the next example. Prometheus. Prometheus took like 5 years of my life. It was my dissertation. I used side change analysis, principal components analysis, agglomerative hierarchical clustering, Barrow's delta, support vector machines, and common engrams. I tried to use as many methods as possible to show like as many problems as possible with the methods, but the thing is that there were no problems. I mean, all methods showed that it's very, very, very unlikely, like I did not consider it possible for this play to have been composed by Aeschylus. It was almost always tied to Sophocles. That doesn't mean that the play was composed by Sophocles. No way, it's not what I'm saying. It means that the machine had to...
Sorry to interrupt you a little bit, Nikos. I'm just mindful of the timing here. So just reminding you that we...
Okay, I'm almost done.
Okay.
This means that the trace, the style of the author was closer to Sophocles, and the machine had to make this decision. A glitch in the process was that a part of Aristophanes' Thesmophoriazus, some lines were attributed to Euripides, but this was not actually a real problem because this was a paratragedy. As we saw in the text, this was paratragedy, and that means that the model itself had like the incentive to see that there was not only Aristophanes there, but also someone else, Euripides. And the ending of Seven against Thebes, we also used some of the same methods, and we showed that the messenger speech about the mutual fratricide, the anapestic opening of the lament, the two personalite dogmiac lines, and the herald vs Antigonus in the last part are tampered. The last one is like most likely not by Aeschylus. It's not by Aeschylus. We used this on Electra, and we on a part that was many scholars thought that was put there by someone else, someone other than Euripides. It's the part that the tutor and Electra fight about the presence of Orestes in Argos. Many scholars thought that this was a humorous bit in the play and that someone else put it there. That's not the case. Euripides actually wrote it. That's what our results showed. And now we're working on the fragments of Prometheus Bound. It's very challenging. It's very difficult. We have very few lines, but we're doing our best. We'll see soon. And thank you for your interest. I'm sorry for taking more time than I had to.
Okay, thank you very much. I think we have time for one question for the speaker. Okay, yes, so.
Do you have a sense for why with the character engrams you'd have to do 3 grams or above, trigrams or above? And what are the character engrams really capturing?
Did you hear that, Nikos?
Almost.
Sorry, will you come closer, please? Just repeat the question.
You want to stop sharing?
Oh, yeah. Sorry, Nikos, remind.
Can you hear me?
No. Yeah, I can hear you now.
So do you have a sense for what the character engrams are capturing and why you have to choose trigrams or higher?
Okay, if imagine that you want to analyze all unigrams, it's like one letter. This mixes things, like it confuses things because it makes the machine go through everything in the text and not combinations in the texts. this goes for bigrams too. Like they're very, very like tiny. This is a tiny combination, and it doesn't. We don't know exactly why trigrams works better. We can imagine, but as you can understand, the more combinatorial entities you have, it works better. But you don't need very much. You don't need many. Many entities in the combination. As for why they work, that's a cognitive thing, and that's a very interesting thing for the future to find out. When we started working on character engrams, we knew even less. We still know very little, and then we just knew that they worked, but for us, they were a black box. Why do they work? Now we can understand that they're cognitive. It's a cognitive matter. And something that I told you before, imagine that the learning model, the machine, like has an overview of all like trigrams, all combinations that you ask him to go through in all the texts that it goes to check at the same time. No human brain can do that. No human brain can process all this information at the same time. It's impossible. But other than that, other than telling you that it's a cognitive matter and that we have to, like, linguists and cognitive scientists have to work together to solve this mystery, there's nothing else I can tell you.
Okay.
Okay, thank you very much. I think